Welcome back to another episode of Fortune or Folly. So here I've got this Xbox Series X, and I'd really love to test it and show you guys the fault. However, there is literally not an HDMI port there. So this is clearly, also you can see the tags born off, clearly been worked on before. So I'm sure that we're going to have another disaster on our hands. But I'm going to get this taken apart and we will examine it under the microscope. Okay, so shockingly, this is not that horrible. It definitely looks like there's some like brute force damage, like they ripped a fucking hole in it. I really hope the planes aren't going to be like too big of an issue there, but I'm pretty sure that's just all ground layer. As for the traces, at first glance, I mean, it looks like they only pulled one off. So let me just clean this up a bit so we can kind of get a better view of what we're working with. Yeah, so only one pad is ripped. That other one that's like half a pad is ground. So it's still gonna connect just fine. Okay, I can't get my camera quite set up right at the moment, so I'm just going to use the solder sucker. I'm going to heat up these post holes and clear them out really quick. Okay, so I think I am going to do this by hand actually, as opposed to using like the hot air station. Just one, because I can actually show people how to do it, and two, because the way that the damage is, I'm not sure if it's going to be easier either way. It definitely seems like it's going to be a kind of a pain in the ass. Also, since I don't have my camera set up like I was talking about before, I can actually show this on camera. Like under the microscope, I mean. Okay, now I'm gonna have to heat up the legs to get it properly seated. So I'm unfortunately gonna have to do part of that off camera. Okay, so I don't know how much padding I actually have here to attach these legs, because I was trying to feed in some solder and it is just not filling those holes. We only have that one little edge on both of those to connect to. But I'm gonna try to just like add a bit more with my iron. This thing is in just such rough shape. I'm not too sure how much we'll be able to do in regards to the legs, which is pretty crucial to stability, so it's kind of worrying for sure. Man, that looks so bad. But it's got like unironically punch holes through the board. Okay, so these last two, and then this one here. Okay, let's double check those again. Okay, that's all set. I am gonna just see, honestly, if I can just reconnect that, because you can see that trace is like lengthwise there, but I don't know if... Oh yeah, that just connected right on, no problem. Yeah. Okay, cool. For stuff like these with ripped traces, I always advise using brushes instead of like a toothbrush, just because they're much softer. So I've got like a fine paintbrush, and you're just kind of gonna do like a sweeping motion. Not bad. I'll just get this reassembled and we'll plug in and test. Okay, so I know I lost a little bit of footage. I don't know how far behind it's gonna be, but here's where we are now. So if you remember in the beginning, I wasn't able to test it. So once I got this HDMI port on, I did the first test, and it was a beep on, beep off issue. And so I go look around the HDMI circuit, obviously, because that has some severe damage. And I find that, remember how these holes were almost like drilled out on the edges here? This one, I followed this trace here, because that trace was open line when it should not have been. And it goes through this hole. So I've severed the lines here. I've put some solder mask to cover it, although it doesn't look beautiful. And then I'm gonna just run a wire over it. So that's what we're back into for. That's so hopefully I didn't lose too much footage explaining the previous events, but that's where we're at now. I wish I had some like coated wire. I don't think I have any. Just like to play it safe, because I don't super trust that solder mask, because it didn't... I was having a lot of trouble getting it to actually cure for some reason. Okay, so let's just... I already prepped those traces a little bit, I just have to tin them. Here we go. Okay, real quick, I'm just gonna check that trace to see if it's still open line, because if it is, that means the boost IC is probably bad. Or the resistors around it, but either way, it kind of blows. Yeah, there we go. That is now 657, which is exactly what it's supposed to be when it was open line. Oh, actually, I believe... Let me double check this last one. I think the last one was also open line, and I don't believe it is supposed to be. So let me check that and see if that was related, because I'm pretty sure that connects also directly to the boost IC. Yeah, it's 657 now, which is normal. Awesome. So I coat that, and then I'll get it together and we will test it. Okay, I've got this hooked up in a testing state, and fuck, the exact same issue. Okay, so I guess it wasn't boost IC related. Well, I guess it could still be, but it wasn't that specific problem we were having. Okay, back under the microscope, I guess. Okay, so I've gone all over this board trying to find the fault for this, and I am at a loss at this point. I can't really find anything else obvious. So before I go ahead with just kind of blindly changing like the retimer or the boost, one of the like main causes for a beep on beep off is this 5-volt regulator just above the ESD IC. So just based on this being one of the causes of that issue, I'm just going to replace it. The only issue is that I'm not 1,000,000% certain if my donor parts are good, but I wasn't having beep on beep offs with those, so we're going to go for it with this. Okay, that was literally awful. I had to take it out from the microscope so I could put like direct heat on it. I don't know why that was absorbing so much heat, but just going to quickly add some solder to those pads real quick because it sucked up most of it with it. Okay, and now to grab from the donor board. I don't know how I brought along a resistor. I don't know how that happened. I guess I touched it up against like right here. Pull it off screen for a minute to get the heat directly overhead. That was really annoying. This feels like my heating element's going out or something, because I feel like that should not have been as hard as it was. Okay, like I said, this was kind of a Hail Mary, so I'm just going to test it off camera real quick and I'll jump forward if it works. Okay, so I didn't record what just happened, so I very quickly turned my thing back on. I was just quickly going to solder a wire on and start testing voltages around the board again. But whenever I went to check, I was just double checking which side was ground and which wasn't. It's not doing it now. The 12-volt side was grounded. It was shorted to ground. And now it stopped. So I assume it discharged and was shorted to ground when it was live? That doesn't make any sense. I'm gonna, okay, let's put on those wires. Let's inject voltage. I don't have a thermal camera, but we can at least follow it. 12 volts. 12 volts. Okay, beautiful. Now, continuity mode again while it's live. Is it somehow shorted? Because it shouldn't be. That'd be pretty bad. No. Oh, sorry, you can't see that. Whoops. But no, it's not. Not shorted. So where was that short coming from? If I turn it off now that I've put injected voltage, will it start shorting again? So it's off now. No. I was wondering if there would be some residuals, but no. Okay. That's so strange. I'm just gonna have to chalk that up to a fluke because I can't get it to do it again. That's so weird. Let's inject voltage again. Let's turn that back on. And let's see. Where is our first point we should check? Let's test. V5. 5-volt rail. Should be nothing, I think, because the daughter board's not connected, which it is. 12 volts, I think, is up here. Yeah, V12. 12 volts, okay. And then we have our 3v3 gated is up here. Yeah, there it is. Oh. I get nothing on 3v3 gated at all. I don't know if that's supposed to be there in standby or not. Let me see. To my understanding, this is a 3.3 volt redriver, so somewhere here is going to be 3.3 volts. Should you be grounded? Let's grab a donor board. Okay, so I just tested on the donor board. That is not supposed to be shorted. So we have a short. We finally found a short. God damn. I thought I tested this chip already, so I wonder if it is what we thought at first and the short goes away whenever it doesn't have power, but that doesn't make sense. I mean, I guess if it's a power management IC, it could make sense, but it's just weird that I only saw the short whenever I had plugged it in. And then there's no short, and now whenever I inject voltage, there is a short. So, but there's no short showing up on the 12-volt rail, though. So it's very strange. Okay, let's go ahead. I'm gonna remove the wires, and then let's try to take that chip off and see if our short goes away. I absolutely despise working on these boards. They just literally take all of eternity to heat up. So let's get our hot air station on. We'll get started. I love having a hot air station that's actually good quality and not that one that was like killing itself, because that came off so easily compared to everything else like I've done with these boards. Okay, is our short still there? Let's find out. It is. Is it the component? Or, well, we can test that pretty easily enough. So that's not shorted on my other board. So where does that go? Okay, let's try to figure this out. Okay, so after finding the datasheet for this chip, that pin is the 3.3 volt rail apparently, so that is shorted to ground. So apparently, what is that? Flux. So apparently, a common issue, especially because we replaced that 5 volt buck converter, but I've seen a couple reports where a capacitor on that circuit has died and it's causing it to not output 3.3 volts. The only thing that sucks is I can't find any resources about where exactly 3.3 volts, like how it flows to the board. So I'm gonna have to just go through and kind of guess, especially since it's not likely to be outputting anything. So I can't even inject voltage for that. If it's a cap, I could use a thermal camera, but I don't have one of those, which sucks a ton. Regardless, let's go ahead and reinstall this chip, since it shouldn't be the fault. Let's look at that buck converter. Let's test some of these capacitors, I guess. See if any of them are shorted to ground like we expect one to be. Oh, whoops, wrong mode. Okay. Is this meant to be ground? Is another question. Let's grab my donor board again. I'm just gonna hold this the whole time in my lap, I think. I'm just going back and forth. I need to be the one that makes a resource guide, I guess. If I get this fixed, I'm gonna make so many, like board details for you guys, because this is so stupid that, like, nothing exists for this board. Like, I know it's not as popular as the competitor, but Jesus Christ, there is nothing online. Okay, so according to my donor board, that is not shorted. So let's remove that cap. It could just be that this cap is on the 3.3 volt line and maybe not actually affecting it. Let's just take it off and see if that short is still present. Okay, let's see if that short is still there. The short is still present. What are you? No short. I believe that's a ground pin. At least that's how it was on my BIOS chip. And I don't suppose these are supposed to connect. I don't think there's one on my donor. Let me double check. No, yeah, that's not populated. Interesting. Okay. What do we have over here? Are these supposed to be populated? No. I have all of these here. I'm gonna assume the full pad here is ground. Yeah. You know what? Okay, I just realized I didn't see if the short was... Oh, I don't know if the short could be coming from the buck converter or if the... Let me try to find the datasheet for this chip, actually. Because now I'm unsure if... I need to know what that value for that pin is supposed to be. Because if the buck converter that I pulled off is bad, I'll have to order one. I'm unsure. Or, well, let me do diode mode. We get 386 voltage drop. And on here it is just 0, right? Yeah, it's fully 0. 520, 500, ground, 340, dropping. That one had a different value for a moment. That is strange. That's just the pad. Yeah, it starts at... When I first tap it, it starts at 400 and immediately drops to 0. That's really strange. Huh. But it's not the capacitor. My main concern is if I pull this off, because this is annoying, this is really hard to get the solder to melt on right here. If I pull that off and the short's gone, do I know if that was caused by this or if something from one of these pads outputs to here and that's actually what's shorted or causing the short? But I guess the only common denominator is the buck converter though. This is driving me crazy. I'm gonna pull it off and see what it looks like. I just have to see it. Okay, it's still shorted. So I do feel silly now because I looked it up. Like I found the schematic after I did this, before I tested it though. And that is intake. That is an intake pin. So 3.3 volts, still shorted. Another thing I found is that this can be caused by the SSD. So I'll give that a shot as well after I resolder this guy back on. Okay, so we're gonna do something kind of silly. So I noticed that while it's not a dead short, this capacitor right here is shorted. So I'm gonna try, because I know that this area does have a cap that can die on its own, I'm going to remove that cap just in case it's that one. But if it's still shorted, we will replace the chip. I know that the HDMI circuit can cause no power issues. I really don't think that this is going to work, but I'm kind of running out of options other than just blindly replacing power management ICs, despite them all looking good. So we're just going to remove that and just see what happens, pretty much. Okay, it is still 0. So I don't have a boost IC to replace it with. So let's take it off and we'll bypass the ESD booster. Ah, this sucks. Because I'm not doing it blind. It is shorted. But it still feels like this isn't going to be the problem. And we're just going to do this for nothing. It's kind of frustrating. Let's get this removed. It is giving me such weird values. It's so weird. It's jumping between 1.7 and 0. With little jumps up to 2. What the hell? Okay, so I've got a diagram pulled up for the bypass. Let's go ahead and tin these pads with some leaded solder. Okay, let's test, make sure they're not shorted together, but that they are shorted to each other with this guy. Yay! Okay. It's on. Okay, ESD bypassed. Let's plug this up and watch as nothing changes. Oh, hey, wait, let me look at the diode reading. That would actually give us our answer right here, right now. Let's switch it back into diode mode. Red probe on ground. What do we get here? Fuck! We get 0. That was for nothing, probably. And that runs to here? Wait, where does that trace go? Because it's not this back one. Is there a via under this? What the fuck? What? That doesn't make any sense. What? Oh, but it connects here. Because whenever I had this disconnected, that was high. So that indicates to me that it's actually this plane specifically, because whenever this was disconnected when I tested it, this was like 600, I think. But as soon as they're connected, so it's this via, or this plane. No, it's this via specifically, actually, because whenever we removed this, we tested it, and it was this. So it's this guy specifically. Where does that lead on the board, though? I really wish I had a board view for this, because I have no way of knowing what that is supposed to be right there. I'm gonna test this anyway and see what happens, but I really, it's not looking good, to be honest. So I've noticed something interesting. This is presumably the 3-volt plane, because this test point and all these components here are shorted, which is new. I swore I tested this area and didn't see this behavior, but I absolutely am now. So I'm wondering if it's this IC chip right here. But what I'm going to do first is I'm going to remove this coil and this cap so I can try to isolate where the short is coming from. So yeah, let's just get into that. And the shorts are all still there. So it looks like it's not this chip, so I guess I'll keep looking. This is driving me crazy. Okay, so originally I was going to skip over this IC because the short didn't go away when I moved the coil, but I have just been informed that this is a voltage step down IC. So I'm gonna remove it anyway, just to find out, because I'm playing it safe. It was worth a shot. It's just another type of MOSFET, I guess. Different model number, similar package. Let's just test around here. I just want to see what these look like for reference. Presumably that's supposed to be like that. I'm gonna clean all this rest of them, to be honest with you. Weird. Wait, 85 ohms? Wait, what? Weird. Did it just kill my multimeter? What is happening? Okay, wait. Run that again. What the hell? So, what about these guys? Are these not supposed to be? Are these supposed to have 100 ohms of resistance? What does this donor look like? $150 ohms. But these are all shorted. Okay, wait, so the ones below it are shorted. Let's just go to the bottom. Let's see if it's... So this isn't running in parallel? Whoa. What on earth? Okay, wait, on my donor, is that one just bad? Because this is 150 ohms. 180 ohms. The main thing that's driving me crazy is I don't know where on this board 3.3 volts is generated. I don't know where it comes from. I know where the 5 volt step down converter is. 12 volt, obviously. 1.8 volt, I believe, is on the flip side. But I don't know where 3.3 volts is created. I don't know what component I'm supposed to get that originating from. And when I look it up online to see if I can find if anyone has that anywhere, I can't find anything. I literally cannot find any documentation. I have the schematic, but I can't find... I don't know if I'm misreading it, but I cannot find where it's supposed to be at. Okay, so I've gone through the schematic, and based on what I'm seeing in there, U30, I believe it's U32 and U60 are the primary 3.3 volt chips. And then I can check a couple capacitors as well to verify them. So C424 does not say if it's supposed to be short. I can text the capacitor itself though, actually. Let me pull the schematic back up. Let me see what that value is supposed to be. Whoa, what? Testing in capacitance mode. Is that showing it dead? That doesn't make any sense. Unless it actually is dead, which would be kind of funny. Just a little bit. If that was the cause of all this. Was like this one dead capacitor. 0 ohms resistance and 0 whatever that unit is. Farads, I think. It's supposed to be 1. Let me check on this donor board that I'm not messing up numbers real quick. So, donor board, 423. Let's see what the values read on here. Yeah, okay. This is reading 6 kilo ohms. What about capacitance? How many farads? 274. Okay. Okay. This is good news. Let's first, before we do anything IC chip related, if I remember correctly, the actual proper way to test it in farads, like test capacitance, is to remove it from the circuit. So, let's take it off the board and measure and see if the capacitor itself is bad or if it's just the signal it's getting from the board. Okay, that capacitor just launched to the 19th dimension. So we're gonna skip the testing. We're just gonna transfer the one from the donor board. Same result. So, capacitance test. We get nothing again. Okay. Let's check resistance. We should get around 6 kiloohms. We get 0 ohms. So it is looking like an IC issue. So U60 and U32. Let's check U32. What does this one look like? Exact same situation. So these probably run in parallel, is my guess, similar to the other MOSFETs on the other side for 12-volt rail, for the 12-volt rail. These other ones, at least on the data sheet, I don't think they all outputted to the 3-volt standby. It was primarily U60 was the one that stood out. I'm kind of thrown off by the resistance readings on the coils we got earlier, because it was on the first and last ones, which are the 3-volt rail. I don't know if that correlates or if that's just how it runs in parallel, if that's just how it looks whenever you look at those readings. But I'm going to take off this chip, and if those values are good, then we'll have our culprit. So, and then I'll remove the second one if that doesn't fix it. So, let's do this. Okay, let's look at resistance. Is it still shorted? It does look to be shorted still. It's higher though. It's actually, it's 0.2 and then dropping, which it wasn't doing that last time. .05. This is 2 ohms. Does it show anything on the capacitance? Let's see. Do we get anything at all? Dead short. Okay. I don't like that. I don't like that one bit. Does that change our resistance on this here? Instead of 160, we're looking at 80. What about these guys? Nine ohms? I think they were right around that, so I don't think that's different. Oh, let's check the short on the 3-volt on the 3-volt test point. It has higher resistance, I'm pretty sure, than it did. So U32 was the other one that stood out in the schematic, because that one has a direct line to the 3.3 volt rail. So let's do this. Damn. Okay. Still there. I'm gonna just reinstall these so that I don't get them mixed up. I know they're the same, but we're putting them on with ease because they're pre-tinned with the same amount of solder. Honestly, I see 2 possibilities for this. So, from all the research that I've done, this kind of short that we're seeing here is usually caused when something on the 3.3 volt rail backfires into the APU and kills it. Or I've actually seen someone on a forum had an extremely similar situation to us, and that the HDMI port had a lot of physical damage. As you can see, there's massive damage between the layers right here, and there is I don't know necessarily where it is, but there is an internal layer where the 3.3 volt rail comes up to the HDMI port. At least according to the schematic there is. And in that one guy's case, he determined that the planes were touching where that damage was. And so honestly, I think it's going to be one of those two things for me. I could sit here for an hour and take off every single one of these, and then also every single one of these, and test every single one and see if maybe it's not that. But I feel like, given the state of this device, it's probably a waste of time. So honestly, I think I'm going to go ahead and give up here. I may revisit this in another video if some brilliant minds in the comments can come together and help me out maybe. But unfortunately, I'm going to call this a loss. It was a really good learning experience though, because I tried a bunch of new things with the schematics and everything. So I was practicing a lot of that. But overall, I think I'm just going to call it quits on this one. And I'll set it aside for parts. But anyways, thank you all so much for watching. You have a wonderful day.